All right, guys, today we're going to start talking about order of operations. And so this year we're going to refer to order of operations as GEMA. So you can see that right here, GEMA. In the past, you may have heard of PEMDAS. Okay, you may have heard of PEMDAS. And so we're actually, again, going to call it GEMA. And so I'm going to explain what that means. So G is going to represent grouping, okay? So G is going to be grouping, also known as parentheses. So groupings look like this. You can either have parentheses like this, you can have brackets like this, or you might have those kind. I'm not very good at drawing it. Okay, I'm going to redraw those. Those are pretty ugly. They look kind of like that. Yeah, there we go. And so those are the three types of groupings that you're going to see. And specifically, in order for it to be considered a grouping, you have to have an operation inside. So there has to be an operation to solve inside of that grouping. Otherwise, it's not going to fall into the G category. So again, the G stands for groupings, and that's going to look like this. You're either going to have regular parentheses, you're going to have brackets, or you're going to have these. They're all called brackets. And again, in order for it to be a grouping, it has to have an operation to solve. All right, our next section is going to be called exponents, and we're going to learn about exponents on Thursday. But exponents are tiny numbers that sit in the top right corner of another number to tell me how many times to multiply. So that's going to indicate repeated multiplication. So this times this and so on. That is going to be repeated multiplication. Okay. So, and then M stands for multiplicative. So again, we have our groupings, G. I guess I'll write it grouping. And we have our exponent, E. And then M is going to stand for multiplicative. So multiplicative just means any relationship that is multiplying or dividing. So multiplicative is M, and again, that is any relationship that is either multiplying or dividing. And in this section, we move from left to right. So it doesn't matter what order it's in, we move it from left to right as long as it's multiplicative. And then our last section is going to be called additive. So A stands for additive. And all that means is we're looking for relationships that have an additive situation. An additive is either adding or subtracting. And again, in this section, we move from left to right. So it might be a situation where we go add, subtract, add. Or it might be a situation where we subtract, subtract, add. Okay, and so all of those are just kind of different situations where we would be adding or subtracting. And again, these are all additive relationships. And so anything that's adding or subtracting falls under our additive section. So let's practice. The next thing we need to remember is that we are going to check all parentheses before starting. So we want to make sure that a parentheses really is a grouping and not just a multiplication symbol or a negative symbol. Okay, so you'll see what I mean when we practice. All right, so if you go to your next page, we're going to do these top two examples. So we have 6 parentheses 11 minus 5 times 9. So what you need to know about order of operations is that they are used when you have multiple operations. So we can clearly see that we have several operations happening in this problem. And so anytime I see lots of operations, I'm going to draw my GEMA tower. So I have G, E, M, A. And next to my GEMA tower, I'm going to draw integer man for the M because he is used for multiplying and dividing. And I'm going to draw my positive negative table for adding and subtracting. And that is to remind myself that when I am on this step, I might need to use integer man. Or if I'm on this step, I might need to use my positive negative table. All right, so I am going to start. And remember, I am moving through the problem, and I'm trying to decide which pieces of my GEMA tower I have in my problem. So I'm going to go through, and before I start solving, I need to look at my parentheses. So I have some parentheses here. So my job is to decide, is this a parentheses that would be a grouping, or is this a parentheses that would be something else? And the way you look is you look at the parentheses and you say, is there anything inside to solve? No. What's inside of here is just 11. So it's not a grouping. So I'm going to go ahead and mark off G because it's not a grouping. But we have to decide, what is it? Well, when I look at it, I look in front of it first. And I say, what's in front of my parentheses? A number. When your parentheses has a number in front, that means to multiply. So we're going to rewrite the problem with a multiplication. So 6 times 11 minus 5 times 9. So again, all I did was I just rewrote my problem so that there's no more parentheses. I just got rid of them so that I didn't confuse them with grouping. All right, I keep looking and I say, do I have any exponents in my problem? Is this an exponent? No. Is this an exponent? No. Is this an exponent? No. So I can go ahead and mark off my exponents. And so I'm basically working my way down my tower. All right, so now I've moved on to multiplicative. So I'm looking for any kind of multiplicative relationship, meaning a multiply or a divide. So I'm moving left to right, and I ask myself, is this multiplicative? Yes. So that is where I'm going to start. So I'm going to box what I'm going to focus on, and I'm going to solve. So what is 6 times 11? Well, 6 times 11 is 66, and I cross it off. And then all I do after that is rewrite everything outside of my box. All right, and then I go back to my tower. I'm still looking for multiplicative, so I move left to right. Is this multiplicative? No. Is this multiplicative? Yes. So I box it, and I solve it. 5 times 9 is 45. I cross it off when I'm done, and I rewrite everything else outside of my box. I'm all done with my multiplicative section because all that's left to solve is going to be this subtraction, which falls under the additive section. All right, I have not needed to use integer man at all because these were just positive numbers. And now I have a regular subtraction problem, so I'm not going to need to use my integer table. So I box it and I solve it. I don't know that, so I'm going to come over to the side and do 66 minus 45. 6 minus 5 is 1. 6 minus 4 is 2. I solved it, and all that's left is the answer. So this order of operations problem is solved. I went through my whole tower, and now my answer is 21. Let's try example 2. So in example number 2, it says 10 divided by 2 plus 55 minus 7 times 3. So I see lots of operations, which means I'm going to need to draw my GEMA tower. So I draw my GEMA tower, 4 sections, G, E, M, A. And I draw a little integer man here to remind me I might need him. And a little positive negative table just in case for my additive section. And I work my way down my tower. So my first question I'm going to ask myself is, do I have any groupings? Do I have any groupings? So I look and I say, nope, there are no groupings, no parentheses, no brackets, none of that in my problem. So I'm going to mark off the G. All right, then I'm going to move on and I'm going to say, do I have any exponents? Do I have any exponents? So I look, nope, there are no exponents in my whole problem. So I will mark, oops, sorry about that. I will mark off exponents. And now I've moved on to my multiplicative section. So I ask myself, do I have any multiplicative relationships, meaning multiplying or dividing relationships? So I'm going to move left to right looking. So starting at the left, ooh, is this multiplicative? Yes. So I'm going to box it and solve it. What is 10 divided by 2? Well, 10 divided by 2 is 5. They were both positive, so I did not need integer man. I cross it off after I solve, and I rewrite everything outside my box. Okay, and then again, we start back over and start at the beginning, and we're still looking for multiplicative relationships. Is this a multiplicative relationship? No. Is this a multiplicative relationship? No, it's subtraction. Is this a multiplicative relationship? Yes. So I'm going to box it, solve it. 7 times 3 is 21, and I cross it off. And then I rewrite everything outside the box. So 5 plus 55 minus 21. And again, I've already moved all the way across my problem. So I'm all done with my multiplicative section. Mark it off. I did not end up needing integer man. And so now I've moved on to my additive section. So I'm only looking for additive situations. And remember, we move left to right. So this is an additive situation. So I'm going to box it, solve it, and bring it down. 55 plus 5 is 60. And then I bring down my minus 21. All right. I am almost done with my additive. So I'm going to box it. And I do have 60 minus 21. So I'm going to come over here to the side and say 60 minus 21. I can't take 1 from 0, so I borrow. I end up with 9, and then 5 minus 2 is 3. So my final answer was 39. And again, we're all done with our additive. We have nothing left to solve, and we did not need our integer table. And that's all we're going to practice today, guys, is just the multiplicative and additive relationships. We will talk about exponents later this week.